Okay, so let's change the clock and let's go to homework number 2. So for homework number 2, yes, steel constructions, start the clock. So regarding homework number 2, let's check assignments, and in the assignment we have steel construction homework. So here we have basic description and have additional files, PDF files. So the task is in this PDF file. So each student by its number, the number is located here, gets this representation of the steel construction. These steel constructions are from old books, and some profiles are not according to Europe standards. So in our case, we need to select profiles according to Europe standards. So Europe standards can be found we can go to this page. So on this page, we have steel profiles. We have 3 different languages: English, Russian, Lithuanian. And if I select English, so information about metals. And here we have a steel profile. So for our constructions, we should use European profiles and or German profiles. So we should follow EU standard or DIN standards. So it means if I go to my Revit application, so I will put this inside Teams. So I have UPN profile, so it means EU profile 22. So based on the cost standard, if I go to EU profiles and select cost standard, so it's Russian standard, so I have this 22 profile. So in our project, we need to change it to European profile. So I should select UPN or UPE. So go to the standard and see the same dimensions. So the closest profile to the profile which I mentioned is UPN 220. So here are all the dimensions, and this is schematic representation of this profile. So we should update dimensions of the profile in Revit and use it for our project. So to insert these profiles for this task, let's save our lab work number 5 and create new project. So for new project, I use the template from my work in progress and create new project. So to insert all these profiles, we can go to load Autodesk families, select English, change English to United Kingdom. In United Kingdom, depending on the technique which we will use to do this lab work, we can go to 3 different sections. So structure columns, structure framing, structure framing, structure framing. And also we can go to another location I will show later. So European specific. And in here we can see rectangle profiles, T-shape profiles, U-shape profiles. And if I click load, I get this table and I select UPN 220. And the program will load 3D model of this profile in my project. If I want to draw the drawings using 2D technique, so instead of 3D objects, I should go to detail items, and in detail items, I should look in this classificator, steel constructions or steel elements, concrete connections, structure elements, okay, groundwork, masonry, structure, metal. So in here I have this 2D component, UPN profile, steel sections. Yes, so from here I can select one of these profiles. Let's say this one, click load. And program also provides me some options. So in this case, I don't have an exact option because I'm loading British standard option. So in this case, I should select the closest one, let's say 230, and later change dimensions so I get the same dimensions based on my settings. So I go to profiles or detail items. In detail items, I should look for this detail item profile. So if I move it and create additional view like drafting view, and I put this profile here, so I see some dimensions. So I can put the same dimensions which I have on in my page here. So here I have H and B. So for UPN 220, my B should be 80. So if I go to Revit, so this parameter should be 80. So I select this profile. I click duplicate, UPN 20, and BF I select 80. I go back here, 220 for the cave, 220. TF will be thickness of my wall. So it's represented with letter S. So in my case, S is 9 millimeters. So I type 9 millimeters. TW represents thickness of my this part. So it's T. So in my case, T is 12.5. So let's double check. R1, R2. So R1 is measured, it's radius here, radius 1 here. So for T, let's change 12.5 if I'm not mistaken, or I can check this. Okay, so this one is 9. Okay, this one is 12.5, and this part, X part, is represented by letter SS, if I'm not mistaken. So EE, X line, Y line, A, okay. So I think E should be used. So in this case, 21.4. So 21.4. And I click OK. And the size of this object is updated. And I can use it for my project. And if additional questions will rise during this process, we can discuss it in our Teams chat. You create a screenshot or just write message or make short video and ask the question which object to choose for your project. Now here we have different views. So on the main view, we need to redraw all these drawings. So we can use 3D or 2D technique to do that. And final drawing should look like this one. We need to create structural framing shadows. So here we have the shadows of elements, shadows of connection elements, and material takeoff. And 2D views, in 2D views, we need to provide main dimensions of elements, welding symbols of elements, and also breaking lines, tagging, and all other components. So this drawing is a mix of 2D and 3D. So basic requirement is to make it in 2D, and for others who want more challenges, they can use and try to do and model all these truss elements in 3D. Additional helping material is bolt catalog from Würth. So in here we have all the dimensions and all the requirements for the bolts and how the bolts are visually represented in the drawings. So here we have schematic views, and we should choose all the standard dimensions from this catalog. So we go to the bolt catalog here, and we choose which bolts we would like to use for our project. So construction bolts are described by these symbols, metric symbol. So the bolt is M, metric 20 diameter, 60 diameter, 12 diameter, and here we can see all main dimensions of the bolts, and here are representation how the bolt looks like. So according to the drawing in our task, we should follow these bolts. So as I mentioned, if some questions rise during the work process, we can discuss which bolts to use in our project. Okay, and additional document, Weld standard, European German Weld standard, and in here we have all the basic information about how welds are represented in the drawings. What are the symbols? So the main symbol is arrow with some additional information. So instead of simplification, we use simple weld symbol, simple triangle, and put it on our weld symbol. And we don't use any difficult symbols and weld elements. So my task is to show you how to use it, to know how to use simple weld symbol, and later, if it's needed, you can find all these instructions and modify, adapt your projects based on requirements. So the document is quite long, so the main task is to understand how this small triangle is used, and in the drawings we should show all the welds using this simple symbol. So how it looks on the drawing, you can see on this example project. So here we have this triangle, the size of the weld and length of the weld element. And we use blue fillet region to represent the location of the weld. So this is like visual representation. In normal drawings, we don't put these blue components, but to be able to tag elements in Revit, we need to create some kind of object which can be later tagged and assigned some information. And additional information how to do this you can find in this steel construction drawings YouTube video. So just click this one and you will see all the basic instructions how to do this project. In this example, I show how to create shadows by drawing simple lines because some elements are created by just drawing fillet regions and so on. So in this case, I show simplified version more related to CAD, not maybe to BIM examples, but the basic work technique can be used in this project. So additional maybe instruction or tips I will show later during our projects. And all these truss elements and steel construction elements is located also in your projects. If I open back our project, so like we created truss on the top of our project. So if we remember the truss element which we created last lectures, so all the steel detailing elements, components can be used for these details of these connection points and so on. If we work with 3D projects, it's recommended to use steel tools from the section steel. In here we have connection, automated connections. We can create plates, bolts, welds, and make modification of any steel element in the program. So it's for more advanced users. So for students, I recommend to know how to do all this steel detailing using 2D technique. So to use fillet regions, components, and just simple lines by adding dimensions, text nodes, and some tags. And basic knowledge in your projects. So I showed how to create truss and to make it detailed with all the bolts and other parameters. It's recommended to practice on these tools. So how to use these tools, we can get more details in the help instructions. So here we can see additional instructions, videos, how to model all the steel components. And here the program creates all the bolts and other elements.
This question is the process.
Yeah.
Connection. How do I join
I think you can leave it as it is, or you can use special tools. If you go to the tools and give me control. So in here we have still modification tools. You can try to use these tools, but for your project is not needed to join all these elements. But okay, I will show you basic. So in any case, you can use a connection tool to automatically make a connection between beam elements and truss elements. So here you have a library of connections. So you can select, let's say, beam to beam, beam end to end, two connections. Let's say something like that. I can add, and I can click OK, and I can select maybe several elements like these ones, and say still I would like to connection automation. And from here I can select some connections, let's say gas plate at diagonal. So let's use this one. So this technique is a more advanced technique. So connection type of add-in model, double tube angle, tube brace angle. And I select elements. I select elements. And can you activate window which is hidden?
Sorry?
Can you activate window? I don't see the window. So I selected elements. No. In the bottom, there is Revit logo. Go and Revit. Yeah. Okay, this one. Yeah. So let's select and select. Yes. I cannot go to the bottom. Can you activate this? Yeah, in Revit. Move the mouse to the Revit. Click on Revit icon. Yep. Okay, maybe just cancel. Okay, so in any case, let's use maybe this one. Okay, let's finish. No created elements are visible. Okay, so means maybe it's hidden. So I go to visibility graphics, structure connections, and in structure connections, I check out if all elements are selected. And if it's selected, so it should show me these connection parts. They are identical instances. Okay. Visibility graphics on. Okay, so one technique is to use these special tools. Another technique is to use steel coping. If I select element, I can change reference plane. So it means I can extend element. So in your case, I see element is a little bit too short, so I can activate it. And I can say, let's use this part. And you see it extends a little bit inside. Now when I have an extent of this element, I can use notch, and I can select notching, and it nicely crops the element. After notching, I go to notch distance, and I can say, okay, I need notch 0, and it nicely notches to the element. The same I can do for this one. So I select okay, I select the top part, I select the element, I select notching. By this element, it notches. So here I have 0. It nicely aligns to the bottom part of my beam, and the same technique here. In reality, maybe such connection is not correct. And in this project, we can leave it as it is. So in this case, I can also use notch and use the notching with these elements. And now, if I select only these elements and crop it out, right category, so I can see these elements nicely cropped. Yep. Of course, your floors and your beam is inside element, so it means you need to move your truss down, or you need to move your roof up, so the roof goes on top of your truss. Now it's not correct; it's bad. Now here you see this green symbol. So this symbol represents structure connection. So in this case, I can select a connection type, and it should try to do connection, but in most cases, yeah. So you see it created connection to the bolts and the other elements. Now I have a nice connection here. Yeah, so I showed you 2 techniques how to do it, but it takes a little bit time. So I think it's not needed for this part of project. You need to fix major problems like this roof and the truss connection, and also you need to fix other main issues. So the truss is, I think, the least issue in your project. And also columns should not be in this position, because in this floor, all of the bearing part is done by the truss, and the truss goes and connects to the 2 points. So it means all internal columns is not needed, and you have nice extra clean space in your project. And the last floor is like big room without columns, and you can use it for extra stuff. So it means only the connection points is bearing columns at the end of the truss. So in one end and in another. In the middle, no columns. Is it clear? Okay, open. So you see your truss is closely related to homework number 2. So in homework number 2, you just trying to do all of these specific connection points. Yeah. Yes, your task. Yes.
I'm able to really understand what I need to do because from your example, your setting for assigning and this I really don't know. I don't know what's happening. I don't know.
So you need to redraw this drawing. Redraw this drawing and select all the profiles from the catalog. You have a catalog inside the task. You have catalog of the bolts. You have catalog of the welds. You have catalog of the steel elements. And yeah, you go to this page. Yeah, select English version. Okay, something is not good, not secure. Why it's not secure? It's do not enter any sensitive information. Okay. So, production catalog. Okay, production catalog. Let's see what is inside production catalog. Product offers, design aid, design manual, product gallery, bridges, product field grades, product catalog. Okay, let's try product catalog. Okay, so in here we can select English maybe. So in here you have official product catalog of steel, basic construction steel elements. Here are some descriptions, some manual, and so on. So in this case, we need to check out, you see, profiles like these ones. So if you go back to the task, there's your task, homework. Yeah. So in this, we have basically, this is or IPE shape. These are angle shapes. This is the plate, steel plate, and additional angle here, and additional steel plates on the sides. So it means you need to check the size here. We have the the dimensions of main beam or column. So it's 300 on 400. So I go to this application. So H should be 400, B should be 300. So let's see if I can find such element. So H should be 400, 400, 400. Yeah, 400. Two hundred, okay. Six hundred, 500, okay. 395 and 308. Well, so quite close to the size we need. So you see, this one we have 360. So, or maybe, we have this one. We have 400. You see, 400, 300. So this profile should be as main column in our project. So here you have all the dimensions. So it means all these parameters are described here, and you take all this data from this table. Now in Revit application, can you open Revit? Okay. Yeah. So save your project, open homework number 2. I think you cannot close because additional window is open. So this additional table, steel connections. So you need to close steel connections.
Can you see my screen?
Yes. Okay, so give me, I request the control. Okay, so for this work, we just go to views, create drafting view, select the scale. I think it's 1 to 10 or 1 to 5, depends on your task. Later we can change it. Insert all link. So let's link image, select homework image. It's PDF file. Okay, so cancel and link PDF. Homework PDF. Which one? Tasks. Okay, this one. So let's link which number. 16. Okay, change resolution to 600. So we have nice resolution. Click OK. Place PDF here. Now we need to nicely scale it out. So activate this tool, scale. So put the point on one side and on another side. So I know this is 400, so I type 400 and it's nicely scales. So now I can measure if it's 400. So I see it's approximately 400. So now my PDF scale is nicely done. So I can pin PDF so I don't move it accidentally, and I can enable snap to my PDF file. Now I need to redraw elements. So I go to annotate and I use regions, lines, and components. So for components, I can insert components like bolts, other elements. I go to load family, select English. For the components, to the components, I go to detail items. And in this library, I have a lot of 2D elements. So from here, you can select what you need. So let's say I need steel elements. So I go through the classificator and select structure steel sections. And for steel sections, It's British steel sections. It would be nice to have European steel sections. I don't see them here, so I can try to select different region, maybe Europe. If I don't have Europe. Okay, I see Europe here. So in Europe, I don't have any detail items, only 3D elements. So no good. I can select country from Europe, so maybe Denmark. Denmark also doesn't have such elements. Maybe Finland. Also no. Sweden. Also no. Okay, only United Kingdoms and Belgium. No detail components. If I select USA metric, also we don't have European specific. So if I change language, let's say to German, in German I will find such elements. So I select the category detail items. And in here I just go, and in this case it's a little bit complicated because everything is in German. I can try to find drag thing. No. Or I can try to go through elements down and check it out for the steel. So all these are 2D elements like AutoCAD blocks, and I can insert them in my drawing. Some of them are parametric, so I can change dimensions and other things. So in this case, I need to find steel elements. Okay, let's go down. Strange, I don't see any steel elements here. Okay, in here I don't find it, so let's go back to English and British catalog. English, United Kingdom, detail items. So in here I need steel profiles, steel sections. I will choose something close to my need, and let's say maybe this one. Click load. And when I load, it proposes me some profiles, so I can select, let's say, which one is closest to my needs. I have 400 and 300, so it's all approximately. Let's choose this one. And if I go to annotation, I put components, and I can use space and rotate this object. So here I have this profile. And of course, I should go to edit type, click duplicate, 400. And change all these numbers according to the catalog which I showed. So technique number 1 is to use detail components. Technique number 2 is using region elements. So from here you select needed material. If you don't have, so you need to create material. You can choose, let's say, any of provided elements. Click edit type, click duplicate, and steel file and 400. So in here, fillet, foreground fillet pattern. So it means I use it as solid. No, so in this case, I should use maybe not solid, maybe some hatch pattern. So in this case, foreground I don't need. I just need the background. So background, I should select white. So I select solid color and select the white. It will be white color. And it should be masking. And in type comments, I write steel profile. In model, I can write model M500 and can put additional details or put the link to the catalog and click OK, apply. Okay. And now I just use a rectangle tool and approximately I draw the box. I select the line and change the line so I see it's 400. I write 400 and external parts, external lines, I change from the thin line to invisible line. So it means it will be like open part here. Invisible line, invisible line. Side lines, I select and choose the line according to ISO standards. So in this case, my line should be continuous and I need to select the thickness of the line. It's 0.13, 0.18, 0.25, 0.35. So if my object is not cutted, I think if I correctly remember, it's 0.25 millimeters line thickness. And now I have nice line here and I click finish. So I have a nice white box on top of my profile. Now to draw additional lines, which I have in my element, I select detail lines and draw additional lines. So I select the same thickness. So it means I go to continuous and I just draw the line down. And the distance from the side should be according to the profile. So it means I can put temporary dimension just to be sure. It's 33. So I go to the catalog. Can you open the catalog? So in the catalog, let's check. So the thickness of this leader part, I see it's TF. So head is TF. TF is 24 millimeters. So let's go back to Revit. So it means this line should be 24 millimeters from the side. Now I have this line. I use mirror tool and I can just mirror it to another end. Okay, so one profile is drawn. So now I need to use the same technique and draw all other elements. Now if I have a building plate, so steel plate, so I also go select region. I can click edit type, click duplicate, steel plate. Dashes represents it's a plate. So let's say 500 millimeters. And later I can update this. So the model will be 500. And it's steel plate. And I click OK. And I just draw this nice rectangle in this location. So I see the size of my steel plate is, I select and choose correct line. So 25. I put additional line here. And it's best if I choose it before I start drawing. So I select a line and it later will remember. So I draw additional line here and I can use trim to trim nicely. And now I put dimensions. So I know what it is, the needed dimension and size. And I can create continuous dimensions. Okay, 64. Put all needed dimensions so I can see the real size of my object. Okay, so this line should go by 10 millimeters, 410. Okay. Now total size of my element will be, so I select the bottom part and type here equals 380 plus 80, and I click enter. 460. The size is nice. Next part is here. So this line should go by, I don't know. So if it's 80, so this small gap should be about 10 millimeters. So let's make assumption it's 70. And I have a nice line here. And additional dimensions I put on the bottom part so I can measure the distance of this cross section, and I see it's 150. So let's select this line and I type 150. All good. 150, 260, 70, 390, total length 460 and 410. So now I can update my name and my name here and my model. So in this 410, 460. And here, plate for 10, 460. And of course, for the plates, I should provide also the thickness of the plate. So the thickness of the plate, I should check out from this drawing, I think. So the thickness of the plate, I don't see, it's 20. So I can, on this dimension, I think it's 20. Yeah, so I edit type and just put additional dimension, then 20 millimeters. So it's mean the thickness. So I just provide the total length weight of the plate. Later I can cut out small parts and so on. So I click finish. So for the building site or the person who will make all this in the factory, he needs to know the size of the plate. So he cuts out this large piece of plate and later he just cut out this small part. So now I have this plate and I just draw another rectangle and another components. Now I have axis lines. So axis lines I should draw using annotate detail lines. I select from here center line. So center line, I think 0.25. And I need to put it in also in nice position. And I just put the center line. And later, let's put example. I just put, let's say, this beam element here, beam, angle beam. And now I have, this is on the top, this is on the bottom. So if I need to change position of my element, I can use bring to front, bring to back. And now, according to drawing rules and standards, I need to see hidden lines. So show hidden lines. Activate this tool. Okay, I select first, pick select element to show hidden lines through. So I want to see hidden lines through this element. And now I show which element hidden line should be shown. And now I see nice hidden lines represented here. And by using this technique, I can just draw elements nice. Next, I create sections. So section, I put and select which view to use for my section. And I just create a section plane. And later I can go to this section and do additional drawings. So now I don't have any other drafting views. So normally for each of this view, you need to create separate drafting view. And later, all these three different drafting views should be combined in one sheet. Also, you should put a breaking line here. So it means you go to annotate, components. So I need to look for the components, breaking line, breaking line, breaking line, break line, and I just put the break line here. And I do it like in the test. I extend break line by 5 millimeters on the ends, and I have nice break line here. Some rules provide possibility to create break line like this curved line, but in Revit, I think curved line is maybe more complicated to create. So I recommend to use this this component, detail component, and create breaking lines. And for main truss, you just use basic lines, and you can create truss schematic view of the truss. Is it clear now how to do it?
Yeah.
Any questions? And additional things what I can mention. So we have welding lines, welding. So for the welds, normally according to standards and rules, we don't show visually welds, but because we are making a BIM project, so I recommend to show welds. So I create weld, additional style, and instead of white color, I maybe use blue color to identify the welds. And instead of 25, I select thin line 013, and I just draw the box like this one. And the weld should be in our project. Let's use only 6 millimeters. So 6 millimeters weld, and the length depends on element size. And now I have nice weld. After I put all the bolts, I go to Annotate tool and I use Annotate, and I just put annotation for all the elements. And for the welds, I need to use specific symbols. So for the weld, I need to use weld. The weld I don't have here. So I need to go to Trimble Connect and select the weld. So in here, I can choose, I want to see the model, and I have nice model code here. If I select this one, okay, so it's wrong element, but if I change to the model, I have nice model. Now for weld, I should go and insert weld symbol from the library. So if you go to Trimble Connect, go to Trimble Connect, let's go to project, go to documentation, go to the library, and use search tool and search weld on the right side. Click, yeah, welding, enter. Yeah, so we need this object. So click, yeah, upgrade, and give me the control. So now just use load into project and close, and I just go to drafting view and put the weld symbol here. So weld symbol is placed here. So now I just need to add the leader, and I use the weld symbol leader to pinpoint my weld. And in here, I type the size of my weld. So here is the representation of the weld, this triangle. And this one, I think, is the length of the weld. I don't remember nicely all these markings. So you should open the weld catalog. Can you open PDF welds? Go to the browser. Yeah. Welds, welding standard. Go down, din. Give me control. So here we have welding, European standard weldings, and in here we need just the symbols. So in here we can see they use a lot of different types of symbols. So basically we use this basic symbol from the catalog. Like this one, but let's see in example. Yeah, so something like this. We have 10 millimeters weld, so it means connecting to two perpendicular objects with this kind of weld. So our weld is looking like this one. So in these pictures we can see we don't show physical weld element because we are using this special symbol, but in our case we are showing this one, and what number should be implemented in the symbol. Let's go down. Here we have a lot of examples. Weld on arrow side. So 300 means weld on the other side. So the thickness of the weld, I think. And you go to the top. Okay, stop. Let's see some explanations. Symbols, elementary symbols. Okay, symbols. So we have the symbols, and our symbol is triangle. Okay, fill. Now we need information about the text. So supplementary symbols, no need. Okay. Position of symbols on drawing. In general, yes. So here, arrow line, reference line, identification line, welding symbol. Okay, Z, from here you can see Z represents the length of the weld. A represents another direction length, so it means this size. So our number, our value is Z, so 6 millimeters, and 300 I think is the length of the weld. So in this case 300. Yeah, I think it's the length. So Z6 and the length is, let's say, 300. Can you go back to the Revit? Okay, so in this case, I write Z6 and the length of my weld. I can just put temporary dimension to check what is the length of my weld. $165, yes. So I put here 165. Yeah, so I have all this weld size is Z6, symbol length 38, length 165. So symbol length, I think I can make it smaller. 20. And I don't know, symbol length is not reacting. Okay, in any case, I have this this number. And of course, in the drawing, it's a little bit complicated when you have a lot of welds to show all the symbols. So you can put extra leader if the weld is the same from both sides. So you can just show by using extra line for the weld. And the symbol, I don't like it because it's maybe too long lines. And but in this case, we have this this kind of symbol in our library. So first use it, add all the elements, all the information, and later you can, if you want, you can modify and make it more beautiful and so on. Is it clear now? Okay. Any other questions?
And for this third one, so is this also a plate?
Yeah, so what does it mean? You are looking, so I always recommend for the students to create these elements on their project. So let's say I will delete all elements here I don't need. So in this case, I go to structure. Let's say I put a column. So it will be like a steel column. Let's put like just rectangle column. And the beam. Steel beam, I don't have steel beam. Okay, so I will put just simple beam. So in our example, if we go to drafting view, so we have a beam here, we have a beam going by diagonal. So it means I create additional beam here, and I rotate it. Okay, let's work plane, edit work plane. Okay, so in the first view, you can see view from the side. So it means from, let's say, from the left. And in another view, you go to, let's say, from the front, and you see the front side. So it means it's like this one. And in this example, you have a plate which goes from this element to this element. So if I select steel elements and select plates, so it means I can pick a plane. So one plate is going like this one. I have nice plate here. Okay. So I have the plate here, and another plate is located labvakar. Gerai, tai atlaisvinsim.
Jeigu kartais išgrėti,
Ne, tai prašom, galit jau įsitaisyti, mes čia tik diskutuojam konsultaciją. Gerai, tai čia, tai aš raktą paliksiu. Gerai. And here you see I put the plate on the side, yeah? So if I look from the side, so I see the plates like this one, and if I look from the front, I see my plates looking like this one. So of course this plate is not in this position according to your task, so I need to move this plate and maybe in the middle of my element, so it's more like this one. So logic is like that. So for students, I always recommend to make 3D model because it's much clearer what you can see, because in 2D, it's a little bit difficult to understand what you'll see. So if you want, you can do the 3D model of this, and it will be much easy to understand what you see. And all these 6 elements are the bolts. So the bolts which connects the plate with this profile.
If I was enjoying so the job then I can use simple, right? Yes, specific so but it doesn't begin of the line.
Now you just go here and just select the bolts. Here are the bolts. Select the needed metric diameter. And go to Annotate, Components. And here are the bolts. Change size. And if you want to put the bolt in this position, so I repeat the same steps. Go here, select bolt from, let's say, this side, or this one, or let's say this one. The same diameter. Annotate, components, and place in the correct position. Done. What's else?
Thank you very much.
Okay, great. So good luck finishing this work, and submit the works till the end of this week so I can put the grades.